So welcome to another episode of Promote Science. Today we have a very special guest amongst us, Madam Professor Judith Karpen. She is currently the head of the Space Weather Lab of NASA, National Aeronautics and Space Administration, which does not need any further introduction. So welcome to Promote Science, and today we would like to have a small chat with you. So our first question is how do you get motivated, or how did you find science as a source of motivation to continue your research or study?
So from being a child?
Yeah.
Yes, so I was always very curious. I think that's the big thing, that you have to keep your curiosity and your interest in why things are the way they are. I know when I was small, I read many books. I was collecting rocks. We'd go out in nearby area where there weren't any houses and collect plants and do things like that. So I think it was really the curiosity about the natural world that was a motivating factor. And also, along the way, I had some good teachers who encouraged my interest in science. Nobody in my family was a scientist at that point. And I had a 5th grade teacher who was herself a biologist, and I think she was kind of the earliest one who encouraged me.
Then how do you get interested in this particular field, like space weather or some solar system?
Yeah. Well, it was kind of by chance. I wanted to be an astronomer since I was little.
Okay.
I just wanted, I read
That's
science
probably everybody's
Yeah.
yeah.
when I was little. And most people grow up and decide to do something more sensible. But,
Yeah.
but I stuck with it, and so I was a physics major as an undergraduate, and got a PhD in astronomy. While I was there, I thought I was going to do research in extragalactic radio astronomy, which at the time was a big thing. It was a new thing. And then I got to graduate school, I took a class in it, and I wasn't so excited about it, but I had a summer job working for a group at Goddard at the institution I'm at now, working on X-rays from astrophysical objects. And in that group there was a woman who was doing X-ray observations from solar flares.
Okay.
And so she asked me if I wanted to come back and work with her the following year, and I said yes. So at the time I did not even know that people were studying the sun.
So this is, I would say, a coincidence that you came into that field.
Serendipity, yes.
Yeah.
Yes, very much. But I'm very glad that it happened.
Yeah.
The sun really motivates you, isn't it? Sun.
Yes,
Yeah.
yes. I mean, it's close enough that we can see a lot of the detail, and has very interesting physics because of the magnetic fields and the ionized gas. And you can't make things up too easily because we can have good observations and test out our theories and things like that. But there's still a lot of questions. So I'm not out of a job yet.
So my question is, how can you explain your research in a very simple layman language so that students can understand?
Especially for, say, undergrad students, like class 9, 10 students, so those who are just started to pursuing science as a major subject.
I see.
Very beginners.
Yeah. So my personal research is on understanding why the sun erupts, why we get things called solar flares, and why we get these big ejections of mass and magnetic field from the sun that actually travel to the Earth and cause problems here, potentially. And I use computers to try and test out ideas about why these eruptions happen. So I'm focusing now on particular theory, particular idea of why the sun erupts at certain times, and we use a computer to solve the equations of mass, momentum, energy, and magnetic field, basically, that would govern the way that the magnetic field moves and the way that the gas around the magnetic field moves, because they're linked together. And so the computer basically runs in time. We try moving the magnetic field around in a certain way to see if it produces the effect that we predict.
So it is basically the computer and all the stuff which you use.
It's large computer codes that run on these supercomputers. But I also do very simple calculations in these one-dimensional, basically predicting how the gas would act along a line or in a tube, to test out some other theories. So that's just one aspect. There are many people that do observations, and so our theories are okay, but until you can test it by looking at observations of the sun, it's, you can't say whether it's good or bad. So you need people to do observations from the ground. They have a lot of solar telescopes. You need people to look at space data, the data that comes from the various satellites that different countries are now sending up. And most of it you can access through the internet. So there's a lot of international
So currently this has been open like before 20 or 25 years from now. So then, I mean, the opportunities were quite less.
Yes.
So now it has been quite wide.
Yes, and I think it's been for the benefit of the field and all fields really.
Yes.
That I mean, right now my brother is in another country doing his sabbatical, working with a biophysicist that he would never have worked with otherwise, and I get to travel and go to places like here at IISER, and talk to people there and talk to colleagues, go to international meetings, etc. So it is very much a worldwide effort, and for the space weather in particular, it's a worldwide effort because the sun is always doing something, and any one country can't really observe for 24 hours.
Yes.
So, ma'am, can you say something about the importance of space weather and what that is doing?
Sure.
Common mass.
Okay, so space weather is just basically conditions in space that affect humans or technology, satellites, things like that, that are out in space, and also affect the conditions all the way down to the ground on Earth and other planets. And the reason we should care about this is that communications, when you have these big solar eruptions, communications can be disrupted, your GPS signals get lost, satellites can be damaged, you can have harmful charges go through the electric power grid as well as oil pipelines and things like that. And even in India, which is not near the poles where a lot of this activity happened, you get effects in the ionosphere, one of the layers of the upper atmosphere that can severely disrupt communications. And unless we can predict these things, you can have a airplane flying and temporarily lose its connectivity, and that's not a good thing.
Yeah.
So it can affect entirely this space weather is very much included in everyone's life. It can affect,
It's very local, but it's also global.
Very global.
Yes, because once you have these eruptions that head towards the Earth, it's sort of like having a giant lava flow, or some kind of big force coming out the Earth, and just by pushing on the magnetic field that shields the Earth from a lot of the effects, it can cause global scale changes in the currents, and it can cause particles to come down, high energy particles. It can also, you get radiation, enhanced radiation from the sun. So all of these things can affect many different.
And we have already seen some effects, like some holes in the ionosphere spheres that affected like skin cancer or something.
Oh,
Ozone
okay.
layer and all this stuff.
Yeah, the ozone layer does have some relation to the UV. Of course, the big problem was humans for the ozone layer because we're putting CFCs into the atmosphere that were destroying
The ozonosphere.
the ozone. But you know, we don't always know the consequences of our
Yeah.
actions.
Yeah.
So here the magnetic field of Earth is
Mhm.
acting as a shield for this incoming
Right.
flares, solar flares.
Right. If we didn't have a magnetosphere, we probably wouldn't have life on Earth. So we're lucky.
Yeah.
And that's a big question for other planets. We are
Yeah.
now observing other planets around other stars, but the question is, how does space weather in those systems affect the probability of life and the continuity of life or the type of life you can get? So those are some of the very interesting questions that people are addressing right now, and that young people can train and work on.
Yeah.
So ma'am, another question that apart from doing research, what other hobbies, anything that you do?
Do I have a life? Yeah.
Yeah.
Yes. So yes, I enjoy knitting. I do knitting. I work in my garden a lot. I enjoy my garden, at least when it's not cold. And of course get together with friends and family. Let's see, I do cook some of the time, but mostly my husband does the cooking. We cook a lot of Indian foods.
Okay.
Yeah.
So this was another question. Like you have came to India, probably I don't know how much time. Is it the first time?
No, this is maybe my 6th or 7th.
Okay, so now you know and much things about India. So how? So this is we are doing for mainly Indian students. So
Yes.
how do you see India as a field of science now? So
Well, I've always been impressed with the amount of science and engineering and mathematics that's come out of India. I mean, historically, of course, there was a long tradition of mathematical research and also scientific and astronomical observations. So I am particularly appreciative of the fact that the government is supporting science and engineering at a large level, certainly compared with the US. And that the people themselves there's a big emphasis on education in this society that it's the same as what I grew up with.
yeah.
My family and my culture have big emphasis on education. And so I'm happy to see that, and I'm happy to see that that hasn't disappeared in the modernization and development process. I hope that both development and the emphasis on education will be able to continue the same way. But another thing is the space program in particular has been growing very rapidly, and there's now a official memo of understanding between ISRO, the space agency, and NASA in heliophysics, in my field of research. And that's one of the reasons I'm here, is because Dibyendu is part of that committee.
Yeah.
And I'm also part of that committee, and Nat Gopalswamy, and a bunch of other people, few other people that we know. So we're really trying to find practical ways to collaborate on education, collaborate on scientific exchange, make it a little easier to work on spacecraft together, maybe even get some launch opportunities here for low latitude launch that we don't have in the US as easily. So there's a lot of ideas, and this afternoon I'll be talking more with Dibyendu about trying to identify some ideas that can be implemented more quickly.
So we have come to the end session of this short talk. So our last question is, how do you see the opportunities in your field or the particular field of space science? Maybe it can be space weather or solar physics or whatever. So what are the opportunities, especially for school students or the young minds, those who have just passed out schools currently joining science as a major.
Right, so, I mean, any
Here
kind of
and
science.
also in, globally.
Okay, that's a big
After
question.
12th class, there is no such program, it's
Directly.
direct program of space weather and all this. You have to go through some certain.
Sure.
Can be indirect also.
Yeah, I mean, for that, you know, you go through an astronomy or a plasma physics or space
Even
physics.
meteorology, as you told in the.
In weather, yeah, you can do some of that, but you need to have a little different physics for the magnetic field, to understand the magnetic fields and things. So, you know, basically you have to have a strong mathematical background. You have to take whatever courses are more relevant. If you want to go into biology, you know, you have to take chemistry and biology and things like that.
Statistical.
Right, statistics, if you want to go into it. But we also need engineering, because you have to build complicated instruments and complicated observatories and complicated spacecraft. And so for all of that, you need to be able to innovate and to find the cheapest but most reliable way of sending things into space, because, you know, it gets more and more expensive. And, you know, who knows how long that the government will be, you know, any government will also be supporting, not this one, but just anyone, will be supporting those type of efforts. So I think take as many different courses, you know, as you can that you find interesting, to be a well-rounded person, but also I think the future is pretty bright for people in science. There's always more questions. There's a need for people to understand the environment, to understand the atmosphere, to understand how to make better solar cells, you know, things that will help humanity as well as the other life on the planet. And all of that is scientific and engineering and technology related research.
Okay, then let me ask you one last question. What is the current status, like opportunity-wise? I mean, how much do you need? I mean, is it already saturated in terms of, I mean, number of scientists or number of, I mean, the amount of technology which is currently built up? Is it sufficient, or do we need more? Of course, for any field, it is not enough, but still I'm asking in a global sense, like, is it satisfactory, or?
Well, you know, it really depends on what field you're talking about and what
I'm currently
aspect
talking
of
about
it.
your field.
No, I think space weather is a growing field, because before people tended to only study the sun, or only study the solar wind, or only study the near-Earth environment or a planet.
Planetary systems and all.
Right, and there wasn't a lot of crosstalk between them, but now trying to put it together as a system is very difficult. And we need people who are very good with computer programming and working with computers. You need people who are very good with data analysis and observations. Now, on the other hand, there is a finite number of faculty positions, you know, at universities, etc. I don't know about the situation here in India, because you're always growing and putting in new institutes, so that's a good thing. In the US, it's been a little more of a problem to try and keep it kind of grows and syncs with the federal funding.
Okay.
So we have NSF, or the National Science Foundation, and we have NASA are the main sponsors of research in this area, with a little bit of funding from the Defense Department. And so I think anybody who's really determined, you know, really is just interested in go into it, and somehow you'll find a way. I mean, when I was in graduate school, we were told none of you are going to get jobs. That's what we were told, and so, you know, somehow some of us managed to get jobs.
Yeah, that is the story everywhere, probably.
Yeah.
So thank you, ma'am, for taking part of Wrong Science, and
My pleasure. Thank you. Thank both of you.
So we have one